Thunder, if you got a question, feel free to send it. Jed, congratulations on the first. And congratulations on keeping your streak after I, tried to deceive you and take your streak away. YouTube streams up. Save the streak. Oh yeah, you said today be a long day for you, Jed, so I hope that it's not going too bad. Gonna end on time? Okay, nice. I know Thunder, if you're still watching an ad, but I specifically made your stream crash, so you'd have to watch another ad, so I make another like 20th of a cent. It's my evil plan. How much money do I even make off ads? Well, let's see. It's only the pre-rolls, to be fair. It'd probably be more if I turned on like the regular ads, which I have zero plans on doing. Oh, you know what? Okay, on May 18th, I made 13 cents off ads, apparently. That's more than I thought. May 17th, 18 cents. I guess I must have gotten rate on the 6th. I made 43 cents on a Thursday. You know? Okay, this is... on Sunday... When did I stream on Sunday? Oh, it must have been from VODs. I made 2 cents. Okay, Evil Dawn. Oh, God. Okay. Do you want to have your question answered first, or do you want me to draw Evil Me first? Okay. I'm happy to do either. I just want to... Physics? Oh, God. Okay. Okay. Frictional forces. Okay. Yeah, I mean, I'll try it. Although I assume you have the expectation for how this will go, which is like me going and for 45 minutes. Electricity equations? Yeah, I've been studying it a little bit. And Coulomb's law. Know that. If you want to just send the question, like, and I'll just see if I can do it or Google what I don't know. Uh, if you want, just send the question, or I mean, if it's easy, just send both. But you can start with just the question if it's not easy. Like if it's easy for you to send both, then I guess you may as well. But you're stuck on the last part, and the second last part you can skip and look at the answer to the rest. Okay. All right. Hey, literal inflation. You have a general question if you aren't answering something? I'm about to pull up a question from Thunder. If you want, you can ask your general question anyway. Because this is probably going to be involved and take some time, so... if it's going to be quicker, I'll, like, do yours first, and then... come back to Thunder's. Yeah, it's literally like, this... The questions that Thunder asks have literally taken me like 45 minutes to do, so don't feel like you need to hold it back. Just go ahead and ask if you want. Record pace is 10 minutes. Yeah. The angle of rotation for a matrix. Also, if you have the end result and you want to figure out what the angle is, or do you just mean like the rotation matrix in general? What is it for 3x3? I only learned it for... Okay, yeah, because like if you wanted to... Oh, yeah, it's more complicated for 3x3. Because if you wanted... Like, in the simple case with 2D, you just... If you want to do a 30-degree rotation, you just plug 30 into this formula. But you're maybe not asking that. Choose value that both work, similar formula. Let's see if I can find it. Oh god, what is this? Hey Eldritch. I'm doing good, how about you? Oh, and literal inflation, thanks for the follow. Wait, did I say this or did someone else say this? Oh, yeah, I said, what is this? And you're saying what this is. I get it. Yeah, true. That's a good answer. Free day off? Oh, nice, Eldritch. That's awesome. Yeah, are you maybe given something that looks like this, and you have to figure out what the angle is? Because that's going to become like a unit circle problem, I guess. Your day off for my day of hard work in Missouri. We learned to just put the matrix values straight in. We get given them. I guess I'm confused on what part you exactly want to know more about. Just so you get two answers. One's a negative. Gives you minus sign for a negative rotation. Different answer for the... Yeah, I'm still confused on what you mean. Literal inflation. Like, are you able to type out the exact wording of a question? Or maybe give the examples that Hunter's asking for? Because maybe you're talking about like arc sine and arc cosine, which, yeah, no worries, inflation. Because I think me and or Hunter would know the answer to this question. I'm just, I don't think either of us are clear what the question exactly is. And it's hard to type stuff out in Twitch chat, or it's hard to describe. So I don't blame you. Yeah, but I wonder where the two different values are coming from. There is no spoon. The red pill or the blue pill. You get two values from cosine and sine, 4 in total. Are you talking about like if we took the arc sine and arc cosine of root 2 over 2? Like how do you know which one to choose between, like the quadrant 1 or the quadrant 4 or the quadrant... Okay. I guess you'd have to look at what the Oh yeah, how would you do that? Okay, inflation, no worries. That would make sense, Thunder. Like how would you tell? Like is there like how does that work? Like if you're just given the end result of plugging in an angle to this formula, how do you distinguish between those two results you get from... Well, yeah, so you do have to translate that negative rotation angle for sure. But that's just like adding 360 to it, isn't it? It matches from cosine and sine. I guess, yeah, you match them both. Okay. Yeah, inflation. If it's easier, you can put it in my Discord. If you just want to whisper me on Twitch, though, that's cool too. Just if you do whisper me on Twitch, like just let me know so I know to check it. Meantime, I'm gonna start reading this question. Oh. The meaning of C in the... Okay. Nice Discord name. Okay. So I think that Hunter is right then with you're given this and you need to figure out what the angle rotate, like what angle rotation this thing produces. Oh, it's fine. Inflation. It's not saying, but you think it. Okay. Yeah, I mean, it'll be the same process regardless of what the numbers are, as long as things are unit circle, I guess. Okay. Let's go to the whiteboard, I guess. Okay, so that's our matrix there, and it's only a 1 mark question. Okay. So yeah, I would just think about what the general formula for a rotation is, which is cosine theta minus sine theta, cosine theta. So we get that cosine theta is 1/2, and sine theta is √3/2. So cosine of theta is 1/2 at where is that on the unit circle? Pi/3, and it'll be in quadrant 4. 2 pi minus pi/3, whatever that is. My brain's a little bit slow today. 5 pi/3. Okay. Is that right? Yeah, I think it's right. I should probably check the actual unit circle to verify that, but I don't think it'll be that answer anyway. Sine theta is √3/2 at pi/3 again. And the other one is going to be pi/2 plus pi/6, right? Which is 4 pi/6, which is 2 pi/3. And so we take out of this list of possible answers, we take the ones that match. So I would say this is a pi/3 rotation, or 60 degrees. So that makes sense. Our separate sat down, you actually understand. Oh, nice. Negative binomial distribution. Oh gosh. Oh, the trauma. I feel like I like using this unit circle, but for some reason, like, why doesn't it become big anymore when I click on it like that? So sine is √3/2 at 2 pi/3, so I got that other one right, and then cosine is 1/2 at 5 pi/3. Okay, cool. You get it? Okay, awesome. Yeah, it's just knowing it's like breaking out those two equations and then knowing your unit circle. I mean, I should probably keep on trying to understand the okay, you mean inflation. You at Saylovsky, I haven't actually got around to remembering functions yet. Oh, like with the sine and cosine? Yeah, it's just something you have to... I memorize the first quadrant of the unit circle, and I work out the rest like I did on the board with doing, you know, pi/2 or pi/2 plus pi/6 and stuff like that. The variable circle. Oh, I think I remember that. Conveyor belt used to raise concrete blocks on a building site. The blocks do not slip on the belt at any time. Okay, so you have this conveyor belt going up with a motor at the end. Large view of one block on the belt. The belt is inclined at 23 degrees. The mass of the block is 19 kilograms. Okay. So you're asking what part C means. The motor switched on, the belt and the block accelerate uniformly from rest to a speed of 0.32 meters per second in a time of 0.5 seconds. Calculate the magnitude of the frictional force on the belt. This seems like an impulse question. The magnitude of the frictional force, maybe it might not be impulse, but no impulse? Okay. Calculate the magnitude of the frictional force on the belt on the block. Oh, you know what? Yeah, you're right. I think this is going to be as simple as final speed minus initial speed divided by final time minus initial time, because it's uniform acceleration. We need to get to account for the mass of the block, but like that's how we get the acceleration for F equals ma. The magnitude of the frictional force of the belt on the block. I'm working something more complicated. But I don't think we need to worry all that much about gravity. No. Okay, so I think they're just asking how fast our I think we can just figure out what the acceleration is of getting to 0.32 meters per second from rest in half a second and multiply it by the mass, and we have mass and acceleration, and we don't have to think that much harder than that. Oh wait, yeah, and because we know the friction is purposely opposing the motion forward from the motor. That's why this works, I think. We would need to know the friction coefficient yet, I think, if we were trying to work from the friction, but we're working from the force of the motor, which doesn't care about the friction. It should be equal to the friction. So maybe it's possible to figure this out, or to figure out the coefficient. I don't really get how that would work, but... Actually, wait, did Thunder send the answer to C? Yeah. Delta MV... Oh, wait. What? Would I get 12 with my answer? .32 over 0.5. Would that be 0.64? Or am I crazy? Oh, you have to multiply by mass as well. 0.32 over 0.5 times 19. 12. Hell yeah. If you round. What is the meaning of 12 newtons and 70 newtons? Where is the 70 newtons? Oh, you have to add in the answer to the last one, which is where the 70 comes from. Oh, what? Oh, I forgot part. Okay. block exerts a frictional force F. Wait, the belt, okay, so F is the force of friction the belt exerts on the block. And friction is opposing gravity here. But once the belt actually starts moving, that's a weird thing to visualize. Because friction, it's like it's working in multiple directions. Because I'll say what's, I guess, going through my head right now. I don't know if this is actually true to the situation at hand. But for part B, when the block is at rest, friction is just opposing gravity. But when the block is in motion, I guess friction is pointing straight up, isn't it? Although, I don't know if it's pointing straight up or parallel to the belt, but the point that I'm trying to make is that once the belt actually starts moving, we now have a force going that direction that I think would have friction also going that direction and that direction, which is where I'm getting a little bit weirded out. But I think that's why they're saying the magnitude of the frictional force. So I'm thinking like friction has to oppose something. Can you explain? Oh, sorry. I thought you were just asking about the oh. Sorry, I thought you already understood B. So let me just make sure they're doing sine. Really? 19G sine 23. What? They're missing a 9.8. Or a 10. There's a number missing for. Let me just. And isn't it? Was it G or K? It's KG. Dude, they are all sorts of off, I feel like. Okay, that does give somebody 2. They did not write the right numbers here, though. Oh, wait, I'm sorry. I'm not even showing it right. What did I just do? The thing they wrote here is all sorts of off. It was 19 kg, and they never included gravity, but they still like just this. I get the same answer as 72.8 once I do it the way that I expect it to be done. Why is it sine? This is a weird thing where I don't know if we want the x component or the y component. Apparently we want the y component. Oh god, yeah, you have to like shift your thinking. Okay, so I for part B, gravity's pulling straight down, but the belt itself is holding up a good bit of the force from gravity, but not all of it. The component that is still making it through that's parallel to the belt that's trying to pull it down is mg sine theta. And then there's still a component that's going, I guess, perpendicular to the belt, which is mg cosine theta. Sorry, that would be pointing down, not up. The magnitude of friction. Okay, so friction has to oppose something, and the only thing it has to oppose is the component that's parallel to it, which is mg sine theta. And so if we want to find the magnitude of F, we know it's going to perfectly oppose mg sine theta, because the block is at rest right now. And they're only asked about the magnitude, so we don't have to even worry about like the sign or anything like that too much. We would just say that F is equal to mass, which is 19 kg, times acceleration due to gravity, 9.8 meters per second squared, times sine of the incline of 23 degrees, which is about 72 newtons. That's what they do for part B. It's just, if the block is at rest, you know that the frictional force is just opposing gravity, but only the component of gravity that's parallel to the belt. I guess you would have the normal force that's opposing the y component, or like the component of gravity that's like perpendicular to the belt. I don't know if that helps make it make more sense, Thunder, but I hope that's, I think that's all that's going on with part B. I think that's where the 70 comes from. All right, okay. Because it's at rest, right? It'll, exactly, yeah. Awesome. Now for C, the motor starts up. And so it just does acceleration for half a second. Hey, Fembox. Yeah. It just accelerates this thing for half a second, and it gets it to a final speed of 0.32 meters per second. Calculate the magnitude of the frictional force of the belt. So this is a weird thing where I think we're gonna have friction also working in the opposite direction. But because they're asking about the magnitude, we're still going to add them and not subtract them. And let me, I guess, that's for B. So we still have our mg sine theta going in that direction. But now we also have a force in this direction going up, which is the belt. And so I think what's happening is that friction is opposing both of these things. So there's still that same vector here that's opposing gravity. But there's now a friction that's opposing the motion of the belt, because if it wasn't opposing the motion of the belt, the block would get like flung forward, I think is the point. But the block is staying perfectly on the belt, it's not slipping forward or back. So I think we get this weird double direction like friction, and that's why things are adding. Loving the physics? I don't know if I am. This is mechanics. So we already worked out the F vector going to the right as 72, or I think they just rounded to 70 for some reason. And because the block isn't getting flung forward, or it's not slipping forward, this vector to the left should also be perfectly opposing the force from the belt, is my guess as to what's happening here. I don't know if it's a good way to note like F sub G or F sub belt or something. That's where I'm getting a little weirded out, Thunder. Like, I'm not completely sold even on my own explanation right now. I think that's what's happening, but I it can still be moving with a constant speed. Because just has a force going perpendicular to the ramp, which causes it not to flip, and that force is 12 newtons. Perpendicular to the ramp, causing it not to flip. I don't think the friction can go perpendicular to the ramp. I think friction has to oppose motion. And the motion from the belt is going parallel to the ramp. Also, thanks for the 10 watch streak, Fembox. Wow. Didn't even notice that. You're bugging out. I mean, I'm pretty confident in that friction having to oppose motion thing, but like I'm not like you know that I'm not that good with this, so I have a hard time saying that this is definitely right or definitely wrong. Try part D? Alright. Yeah, because this one, I don't know the formulas for these offhand. No, Thunder just usually DMs me the problems. If you want, I'll show you the original one if you want to take like a screenshot of it or something. Actually, that's probably going to be a little too zoomed out. So yeah, that's the initial problem, and then we're looking at part D next. Yeah, but honestly, the Thunder's probably easier if you just like post it in there in general. Because there might be someone else in the Discord server who's going to like speak up and know it better than I do. 110-volt DC supply that has negligible internal resistance. Some operating current in the motor is 5 amps. Oh god. To reduce the maximum number of blocks that can be moved in the belt at one time. So we need to work out, I guess, the force. The maximum total force this belt could exert. Or the motor can exert. And then figure out the most number of blocks that can fit into that. So the power... I don't know how we're going to use these things, because this is getting... It's been way too long since I've done this, but we can get the power, which is apparently volts times amps, to get 550 watts. And then the energy is the power times distance over velocity, which is time. Okay, yeah, power is energy per second. So you would take, if you want energy, you would take power and multiply it by the number of seconds, which is given by a length divided by length per second, I guess. Okay. So yeah, I guess you can use either power or energy. You don't have to do both, it seems. No, the resistance is negligible. So they start off with, if we just follow the power equations, you can work out the power of the motor using P equals VI. So V is 110, I is 5. To get 550 watts, but it's only 28% efficient, which that's 28% seems really low. I don't know anything about motors though. So you take whatever watts you get and you multiply it by 0.28 because that's only how efficient it is. The power of the energy to move one block. So if you want to move a 19 kilogram block, 8 meters. Okay. For your E equals Fs equation, is S the length? The distance? Okay, good, yeah. Oh, E is the work done? Oh, which is the same as energy. Yeah, yeah. Okay, okay. Okay, so P equals E over T. E equals force times distance. So yes, because we're working, the work that we're doing is against gravity. It's that same 72 that we got in part B. It's like we're increasing the potential energy, which is just the potential energy comes from gravity. But it is the same 72 from part B. Times, I guess it'd be the increase in elevation, not necessarily the distance of the belt. Which is, if that's the 23-degree angle, the hypotenuse is the belt, which is 8 long. The increase in elevation would be 8 times sine 23. What does that come out to be? $85 newtons. Yeah. Well, they said 82 or 85, which I don't really... Oh, because of how it's rounded. It's rounded in a stupid way, but yeah. So if I do the thing that I wrote on the board, 72 times 8 times sine 23. $225. That's not energy. Why don't we consider the force of the velocity of the ramp? Yeah, sure, amorphous. I'm apparently missing something. The energy. Is it really times 8? Sine 23, that's around a half, isn't it? 576, bro. It's just times 8, but I don't get why. Oh, because, okay. We're only opposing the component of gravity that's going parallel to the belt. So since we're already talking about parallel to the belt, the 8 meters is the distance parallel to the belt, not the, we don't want the change in elevation in this case, I guess. What's the unit of energy? I forget. You can remember? Joules? The block is not... The block only accelerates for like half a second. It has a constant velocity otherwise. Or maybe not like half a second, but it's going to mostly be moving at a constant velocity. And I think we just ignore that part. I think it's relevant for the work done Venbox, which is necessary to figure out the energy. I think I got this 580 answer. I just didn't round it. And so, because for 8 meters, we're opposing the component of gravity that is, or we're doing work against the component of gravity parallel to the belt. And so you can get the time it takes to move that block up the belt by doing 0.3, or doing 8 divided by 0.32. Eight meters over 0.32 meters per second, which is a number. $25. So I assume we'd round it to 580 because they're doing two significant figures. Over 25 seconds to get the power. Which is 23 watts. And so it's 23 watts for one block. And the motor we said it is 150 watts. Oops, I'm not showing my browser. So we do 150 watts for the entire motor and divided by the 23 watts per block. And we get 6.5, but half a block doesn't make sense, so we chop it off and get just 6 blocks. So yeah, I think that's how you do it. Oh, okay, $10. Why use 72 newtons, not 85 newtons? Because I think the force of friction isn't relevant for this energy calculation because after that initial acceleration, do you ever do work against friction? Like, you're not gaining energy with that. You're producing heat. I feel like you ignore friction when you're figuring out work done. I'm trying to justify why you actually would do that, though. Because Oh, never mind. For some reason, I thought that friction never comes into play with work, but maybe not. Um, I think so, Thunder. That's what I was trying to initially say, but I couldn't figure out how to phrase it. I think the friction, because of that weird like opposing itself thing that I was saying from part C, the friction might just cancel itself out. Yeah. And Amor, if you want to type in your question, feel free to go ahead. Why don't you consider adding this force as well? It's 25 seconds. Well, you're not accelerating. That 0.32 meters per second is constant. It's not accelerating at all. So it's zero force. I mean, there are forces involved, but they're all like canceling to zero. If something's moving at a constant velocity, then A equals zero. I wonder if P equals FE only applies to some situations, Fenbox? Because yeah, that seems like it's missing. Like, or I guess that it definitely doesn't take into account the length of the belt, which is important for energy at least. I don't know, but obviously I'm out of my depth. So yeah, Thunder, after you put the block initially onto the belt and it gets up to 0.32 meters per second, all the forces on it cancel and there's zero force. It's still moving, but there isn't any force because it's not accelerating. The only force opposing is 72 newtons. Right. The force due to gravity that we're doing work against. I don't think we're doing work against friction. Yeah, because it's staying in the same place on the belt. If it was moving on the belt, we'd be doing work against friction, I guess. It's a weird thing. That's probably why, though. You need help with using the squeeze/sandwich theorem. Well, it's being pulled down the belt by gravity, but it's being pulled up the belt by the same exact 72 Newton force. And it already had an initial velocity of 0.32. So its velocity just isn't changing because it's being, yeah. It's not a constant acceleration. Or yeah, it's 72 newtons on both sides, I guess. You need help using the squeeze/sandwich theorem. Find the limit of f of x in the squeeze between g of x and h of x. I don't understand how we know what g and h are. Yeah, more so the challenge with the squeeze and sandwich theorem is that they can be anything you want. It's just there's only not every choice is helpful though. You have to be creative with it. So there isn't a rule. Teacher never. Yeah, it's just you can technically put anything you want as long as the inequalities are true, but the squeeze theorem only applies in like specific cases, I guess. The net force to move the block 0. I think it's because the belt is still exerting a force to oppose that gravity, even though it's canceling. Like, the belt could just stop and the block is going to fall down, but the block isn't falling down because the belt is doing something. I think that's why, but yeah, you're not stupid, Thunder. I just don't know how to explain it. And yeah, amorphous for limits, I hardly ever use the squeeze theorem. I usually don't get given them. But if you're in a situation where you do have to use it, then you just have to basically be really smart and really creative, unless you've seen the problem before. It can be really challenging to apply it. Uh, because the force due to gravity is always, it's like I think it's a matter of perspective, Thunder. Like the force due to gravity is always there, but like, you know, us, the humans, are making this belt do work against gravity to change the state of this block, I guess. And we care about the force that we're exerting on it to move this block up against gravity. And we happen to be doing so at the exact acceleration that gravity is doing it. But we could also, like, we look only at the force that we're putting into it, I guess. I think is the rationale. What is part C? The force needed to just start it. Yeah, because there has to be some kind of, you know, positive, like the forces aren't canceling out in this part because the block does have to go from rest up to that 0.32 speed. So every time you put a block on the belt, it is definitely going to get, the forces do not cancel and it does get up to speed. Or, you know, it does accelerate. But once like, once it's going and it's up to speed, the belt just doesn't try to push any harder. Force it causes it to start as 85, then it goes back down to 72. I think so, yeah, because the force of the belt has to oppose gravity and friction. So it's maybe initially it has 85 newtons, and then it goes back down to 72, like you say. I think that is accurate. Incredibly realistic? I don't think so. I'm trying to think of a situation that's more like universal, but like I grind my coffee beans fresh each morning, and I turn the grinder on first before the beans are ever in there. So it's moving at like a constant, you know, RPM. But once I actually put the beans in, you can actually hear the motor like slow down as the beans suddenly hit it and it's not ready. So the motor has to like, you know, initially slows down, but then has to like push harder to get back up to speed, I guess. That's kind of how I'm thinking of it. The resultant force is 12. I think so, yeah, Thunder. It's the frictional force, the force pulling the block up. It definitely wouldn't move up if it wasn't for friction. Yeah. I'm not sure of which direction the frictional force is going anymore, but if friction is necessary, like otherwise the block would just like slide around, or like it wouldn't be moving up the belt for sure if friction didn't exist. I'm just not quite clear on whether it's the belt's force. I assume it's the belt's force of pointing like up the belt and the friction is pointing away. I know, I'm a little bit unclear on that part, I guess. Can we just get like a different example that like has this done for us? Like I want to see someone else have completed a free body diagram for this. Huh. Static friction versus dynamic friction. I wonder if that's maybe the concept that I am missing, that I forgot about. Then after that, I reach speed of 0.32 in acceleration. I think so, Thunder. Is this F? Do they say what this F is? That, yeah, and I think what the stack exchange thing is saying is that the nature of the friction changes from when the box is initially placed on the belt and getting up to speed versus when it's up to speed and just moving along with the belt. Or, you know, like the belt is like back up to speed, I guess. Which is where I really don't remember how things worked out, but stream is bugging? Oh no. I'm not dropping frames. Is it bugging for anyone else? Let me pull up my own stream and see if I can see it on my end. It's normal for me. It's weird. It's good again? Okay, if it happens again, please let me know, but I guess I'm gonna just let it be. In the words of the Beatles. Sorry, so this is your follow-up question, and you want to, or a separate question. How do you read the value for the blue line? What? What the hell is this? Logarithmic scale? What are these subticks? I think, 1, 2, 3, 4, 5, 6, 7. Really? 2, 3, 4, 5, 6, 7, 8. So, okay, that's 5 zeros. I do expect it to be, you know, 10 to the 5th is a 1 with 5 zeros after it. More lag? Oh, okay. Why aren't there 10 tick marks between here? Or nine tick marks. 1, 2, 3, 4, 5, 6, 7, 8. Maybe 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 9, 9 to 10. Oh, okay. Well, no, but then why is that 300,000? This is a 1 with 5 zeros is 500,000. Or sorry, 100,000. So this horizontal bar right here is 100,000. This then should be 200,000. And this next tick mark up here is 300,000. It looks like it's just above 300,000, but it's close enough to call it 300,000, or 3 times 10 to the 5th. This is a weird scale. But if they had the tick marks spaced out like this, or I think you can safely assume that each of these tick marks is spaced by like evenly between 10 to the 5th and 10 to the 6th. Why is it 3 times 10 to the 5th and not 5 times 10 to the 5th? Because this horizontal line is 100,000, next one is 200, next one is 300, 400, and then 500 is right here. It's spaced differently because this is using a logarithmic scale. You can still assume that if they're providing these tick marks, that the numbers between them are like, you know, there's the intervals between these like tick marks is still the same each time, but because things are on a logarithmic scale, they get spaced weird. Yeah, so I would like, you're right, it's you know, this box down here is super tall and they get shorter and shorter each time. This is some weird, like, this is a weird, I don't even know what this is. It's not exactly logarithmic scale as I would think of it. Or maybe it still is. This graph weirds me out, but the thing that I'm relying on is that we know that this bar is 10 to the 5th, and this bar up here is 10 to the 6th. And each of these horizontal bars should be evenly spaced intervals, even if like geometrically it, you know, it looks all wrong with like the boxes down here being tall and the boxes up here being super short. That's how I worked this out. I don't know exactly what's happening with the graph, to be honest, but Uh, they're using some kind of weird logarithmic scale. So many orders of magnitude, I'm saying more lag. So yeah, I guess Fenlox, I don't know if you know the answer to this, but like I'm getting confused why this pattern is like, going from big to small is repeating. Shouldn't it just go from big to small once? Like I feel like they're like from 10 to the third, from 10 to the fourth, they're taking the log base 10 to the 3. But then up here, they're taking the log base 10 to the fourth. Up here, log base 10 to the fifth. That's where I'm getting weirded out why it's repeating. And that's the only way I can think of to justify this, but that's weird. No more questions? All right, Thunder. I can still draw Evil Dawn if you want. I don't think anyone else has asked a question in the meantime. Or if you're just gonna head out, I'll give you your points back. Oh yeah, I'll get drawn. At no time? Okay, okay. I'll give you your points back. The first 10 lines are counting by 1,000. Okay, so it is kind of like what I thought. Okay. Yeah, and that's maybe a better way of phrasing it. Yeah, in reality, this graph should be more like an exponential like curve, I guess. If it was actually like a linear scale, I guess. That's what I assume. I don't know. I mean, I shouldn't try to visualize that much, but hey, Rue Mesa. I went to Hawaii Pacific University. How do I keep like scrolling down like this? In the meantime, since I don't think anyone else has questions, Phobos did ask about 1.34 for the reading group. Hey, Nail Maz. So let's take a look at 1.34, I guess. Aircraft carriers and specks of gold. You love meth? You can love meth too if you want, Nail. Hey, Phobos. Welcome in. Speaking of you and you appear. You did 1.34 today? Okay. Nail, if you're interested in more math, I dual stream to Twitch and YouTube. Over on Twitch, there's a whole bunch of people who stream about math. I haven't tried it yet. And on YouTube, someone's gonna start streaming on YouTube on Fridays. Let me get you their link. And so what did he put? Friday, June 21st? Okay. Starting Friday of next week, there's a YouTube channel who'll be doing some math streams too. And for anyone on Twitch, Zach is going to be doing streams on YouTube. So if you're into that. Yeah, welcome in, Nail. No worries. Whenever I see new people, I like to let people know that this community exists because there's some just cool people in it. I mean, how you would, I know if I'm pronouncing that right, by the way. Right, how you would move one electron from every atom in a tiny cube of gold 1 millimeter on a side. Oh, we're moving one electron. Okay. Do the same thing with another such cube a meter away. What is the repulsive force between the two cubes? How many aircraft carriers would you need in order to have their total weight equal this force? That's a weird way of measuring this, but okay. The density of gold is 19.3. Its molecular mass is 197. One mole. I'm glad they give us this conversion with moles. Okay, so we need to figure out how many atoms are in this 1 cubic centimeter or cubic millimeter of gold. What's the hardest thing in math for me? That's a good question. I'm pretty terrible with, like, the more abstract or proofy something is, the less good I am at it. So I'm even like and definitely when people don't have questions, I'm even studying this abstract algebra stuff sometimes. And I would say that that's probably the hardest thing for me, like just like abstract algebra and stuff like that. That's very, abstract, I guess. I'm also studying physics. Like I have up right now, which I'm still not good at, but I enjoy it a lot more at least. Because you took the difficult university exam in Turkey. Oh, really? Hope you did well, Rumisa. I think I'm just going to work on this physics question, if you don't mind, Rumisa. Unless you want to, unless you're, not sure about one of them, you want to see me try one, but, I'm kind of interested in doing this question that I have up on the screen right now. By the way, I hope you did well on it. All right. So we got a 1 cubic millimeter of gold. Oh, and we have 2 of these things spaced 1 meter apart. The density of gold is 19.3 grams per cubic centimeter. We gotta do unit conversions, bro. Density is rho. How do you go from a cubic centimeter? There's 1 centimeter is 10 millimeters, if that's how metric units work. And then you cube all of this. So it'll be 19.3 grams. Oops. We're gonna move the decimal to the left 3 times, I guess. 0.193 grams per cubic millimeter. It's molecular. It's a mass of 197 grams. Okay, so I forget, it wouldn't be A, but like there's a 6.02 times 10 to the 23. 6.02 times 10 to the 23 grams per mole? No. Yes? No. 197 grams. Ugh. Grams per 6.02 times 10 to the 23 atoms. Ugh. Okay. And so we want the number of atoms per cubic millimeter, which we can then multiply by the volume to get the total number of atoms, I guess. So we're going to do 0.193 grams per cubic millimeter divided by 197 grams per a mole. Wolfram, save me. Oh, 193. You're prepared for another year. Your goal is medicine. Ooh, well, good luck, Rumesa. It's a great goal to have. 6.02 times 10 to the 23rd. Okay, we're gonna call it 5.9 times 10 to the 19. Ten to the 19 atoms per cubic millimeter. N number of gold. I mean, I guess they're not atoms, they're gonna be ions if we remove an electron, but who cares? And then times the 19 atoms per cubic millimeter times 1 cubic millimeter. 5.9 times 10 to the 19 atoms. Okay, and that's important because we've taken each of those atoms and removed 1 electron. So the charge Q is equal to, it's going to become a positive charge. If you take away 1 electron, it becomes plus 1e. So it's going to be 5.9 times 10 to the 19e. Coulombs? I don't know, does E already include coulombs? No, it's not for coulombs. E is its own unit. Never mind. Okay. And so what is the force between these two things? We do need to convert the E to coulombs, I guess, which the book did earlier. We're going to plug it into this thing. Where is this conversion? Oh, no, that's K. Does Wolfram do this for me? 5.9 times 10 to the 19. Oh, that's not going to work in there. E2 coulombs. Am I check my sentences correctly? I'm just learning to speak English? Oh, yeah, your English is really good, Rumesa. 9.453 coulombs. Okay. So now that's in coulombs, we can calculate the force as 9.453. I'm going to make it 9.5. 9.5 times 9.5 over, I guess, it's a distance of 1 meter. And I guess we can multiply by K. 8.988 times 10 to the 9 times 8.988 times 10 to the 9. That's the force between them in newtons. It's a lot. I think that makes sense. So we have to take this force in newtons and figure out what the equivalent weight of it would be in aircraft carriers. It's kind of a meme. The mass is around 100 million kilograms. So the force due to gravity on 100 million kilograms 100 million is 10 to the 8 times 9.8. And we want to take this number and divide it by this number. Times 10 to the 8. Let's call it 3, 6, 9, 11. 8.1 times 10 to the 11. $826.5 aircraft carriers? That's a lot of aircraft carriers. What did you all get? But was you got 8.16 times 10 to the 5th aircraft carriers? That's a lot of, that's even more aircraft carriers. Denmark's got 818 aircraft carriers, which we're probably about in line, just rounding. You had, oh, okay. Cool. Glad we got to the bottom of that. The problem is really, it's just a lot of unit conversions. A lot of work. Well, first we have to make one of those cubes. I imagine that's going to be very easy. $48 might be kind of interesting. Charge Q is distributed uniformly around a thin ring of radius b that lies on the xy plane with its center at the origin. Locate the point in the positive z-axis where the electric field was the strongest. Both of us, I'm really strong, so I would just like pinch it together, or just like hold it in my fist. I think that'll solve the issue. Shouldn't it just be like close to the ring? I assume we're not gonna get that exactly. A thin ring of radius b. Like, why would it not be just slightly above, like, some really small z value? Or maybe it is, and that's the point of the question. It has total charge Q. Okay, so how does the force at any point on the z-axis look? We only really care about the vertical component, I guess, because like the horizontal component's going to cancel across. So would we say something like EZ is equal to DEZ, which is equal to the integral? Well, 4 pi epsilon naught. It's radius b. So b squared plus z squared. But we're going to slap a sine theta on it. And I guess probably a d theta. Talking about a differential. Well, wouldn't be we'd be changing z. I don't know if it's. I think I'm confusing myself with this. Because theta is like I want to keep z as a constant for the sake of the integral. Sine theta. Oops, sorry. I feel like we should get a function of z here, but I feel like I'm not going to get one. Because if I do like what I would naturally do here, and maybe I should just keep on doing this and see where it goes. Like, would we integrate this from... Oh wait, or is this just the equation that we want? Do we don't need to integrate this, do we? This is just the field, I think. Thunder? What about thunder? Like, would I derive this instead of equal to 0? Or do I have to, like... Maybe, like, I thought I needed an integral here, but I feel like now I don't. Based off what I just wrote. Hmm. I sneezed? Oh yeah. Differentiate. This is one where I'm gonna feel sketchy about it. What happens if we did take the derivative? You know what? No, I want to look at some of the examples from the books. I feel like I'm doing this wrong. I'm too rusty. It's like I could do a quotient rule on that, but I feel like I'm not accounting for something. I mean, No, they don't do an integral here. Like, I don't think anything is changing, I guess, besides z. I'm gonna take the derivative and set it equal to 0. Try and stop me. Quotient ruling on that. Let's just take the constants outside. Or the coefficients outside, rather. Low d high minus high d low. Wait, I already forgot what I said. You derive the numerator first. So b squared plus z squared to the 3 over 2. Dude, the quotient rule sucks. Least favorite of all the rules out there. Ah, 3z squared. Oops, it's the power of 1/2. B squared plus z squared to the 1/2. Wait. That's not a negative power. It's like that. It's like flips back to a minus. Like that. Factor b squared plus z squared to the 1/2. I mean, we can just set this thing equal to 0. We can say that b squared plus z squared to the 1/2 times b squared plus z squared. Factor the 1/2 out of that. This becomes the power of 1. It's 3z squared equals 0. Okay. So from this one, we don't get any answers, right? No real answers anyway. From this one on the right, we should get something. We're going to square each side and only take the positive because we're only interested in positive z answers. So that's a critical point anyway. We haven't shown if it's a minimum or a maximum, I guess. It's physics. We don't need to do that. Root 2 over 2b. I'm going to Google it though, because I'm not that confident in this. Root 2 over 2b, it feels like it makes sense. Like, it's 45-degree angle. You're guessing Z equals B? You might be right too. Cut to the chase. Come on. A over root 2! Look at me go. That's according to this random PDF. I should make sure it is the same question though, right? Why do they use radius B, by the way? Isn't that weird? Why would you use B? They use A here, which is more reasonable. Well, what's wrong with even R? Alright, so, like, how do they explain this integration part that I just kind of apparently short-circuited? Oh, and then d theta. See, I was getting confused because aren't Z and theta related? Like, or phi or whatever Greek letter this is, I can't remember. Psi. Like, the higher Z is, the smaller psi is. So I don't really get that. Oh wait, they're not integrating psi. They're integrating theta. The hell? Well, I mean, I can't explain why I got what I got. It just makes sense, I guess. If it, like I cannot tutor someone in the question that I just did because I don't know how to explain it. I guess this is where the integral is with integrating around the ring. But you're just going to get the circumference of a circle, are you not? Okay, I mean, this is the thing that I was searching for. I guess it just felt pointless, I guess. I'm just going to say I guess a lot. Okay. Well, that's fair. I'll just accept that I'm right. Okay, I wasn't planning to do it, but this hint for 50 is kind of intriguing me. What is the electric field at the center of a hollow hemispherical shell with radius r and uniform charge density sigma? And what is 1.12? Did we do this? Oh, wait. I put this one down for a while, saying that I would come back to it, and I do still want to come back to it. Okay, but I want to keep looking at 50, but I'm going to go back to 12 next. So we did get that huge hint with using the law of cosines. And doing whatever crazy stuff I was doing. Should be the center of a hollow hemispherical shell with radius r, uniform surface charge density sigma. Because I assume there's some Gauss's law thing that you're supposed to do here. Because I would think that you can make a Gauss's law sphere that has the same center as the hemisphere, but it's just a teensy bit smaller. It wouldn't be enclosing any charge. Which would imply that there's zero field, right? Or I guess the flux is zero anyway. That doesn't seem right, though. It should only be pointing straight up, I feel like. Thunder appears. Cheese? Disappears? Okay. Well, there shouldn't even be zero net. Like, that's weird though, because in the very bottom of the hemisphere, or the very top, that has exactly a vertical field, nothing is canceling that. Oh no! In terms of flux, the arrow in would equal the arrow out. Thunder, what? Okay, so that was you in the YouTube chat. I was like, is that the same thunder? And I'm looking at your avatar. I assume it's Pikachu, but it's too small for me to actually see it. Got recommended my stream on YouTube? Hell yeah. Dude, I'm crushing that algorithm. I'm really not. I don't know how the algorithm works, man. It's so weird. I wish I provided answers. I think I'm gonna Google this one. You see, they do this with an integral. Well, they like. It's electric potential. That's not the easy, like. I guess okay, it's still maybe an. I think there's an easier way than like without involving integration at all. Okay, I don't think you can use Gauss's law to do this simply. Hardlocked? Good morning to you too. How's it going? Yeah, the way this was phrased made me think there was, but a, a, a Gauss's law closed surface that is just barely inside the hemisphere doesn't actually help you because you actually want to enclose charge to get anything that's helpful. And a sphere that is just outside of the hemisphere it's unclear. Ooh, wait, is there something to that? No, it's unclear to me how you would do that. Maybe it's possible. I just thought you'd be able to avoid integration entirely, though. So hemispherical shell, radius r, surface charge density sigma. Do we only care about the center point or the center axis? I guess the center point. Split the sphere up into rings. Yeah. Oh. I'm definitely using rings here. It probably is going to be basically the same thing. $10. Yeah, we definitely want to take advantage of the symmetry with rings here. So the distance from the edge of the ring to the center is r. We can say the ring is radius small r. So if we go from like this ring right here to the next ring, let's say down, I guess we would call that dq. And that would be equal to sigma 2 pi r call that z. Sigma 2 pi r dz. I think it's probably a better way of saying this. And we can say dz in terms of dr. Like that. So we come up here. Is that minus sign an issue? Let's just say it's not an issue, I guess. It'll probably go away at the end. I did it right. This doesn't really feel that right though. There's probably a way easier parameterization, isn't there? If you parameterize in terms of like that angle up there, I bet it's easier. Let's see what that looks like. Because I always default to parameterizing with radius, but we don't have to do that. Two pi r d theta, right? So, and r in terms of theta is what we want. So we want to use sine theta is equal to r over r. That's kind of stupid, isn't it? Because we had to get an arc sine. Oh, wait. No. Sine theta is equal to r over r. We're interested in d theta. Oh. Obi. Thank you so much for the raid. Welcome in. How's your stream? Oh, another best viewers bot. Isn't that great? So around D stuff. Ooh, that's pretty hype. I'm working on this problem out of the E&M physics book that I've been will I could commit to dates? Ooh, great. It's exciting. I'm thinking I might do like an @everyone ping in my Discord too. If you do confirm your dates at some point soon. Because we got like the 3 different classes, so I'd like to do like one post to like kind of cover everything if I can. But of course, you do you. Oh, Harlock, I didn't see you posted a TikTok on my Discord. Well, sorry for that. You're saying 2 pi small r big r d theta. Doesn't that give you volume? Like, isn't that too many dimensions? Oh, wait. No. Yeah, the big r d theta. That's the thickness of the strip. You know, I'm saying like, I guess once you do know dates, I'm gonna keep an eye out for that and hopefully advertise both you and the other classes that are happening a bit. But Obviously, no pressure, and do whatever you want to do. Yes, right. So 2 pi r is the circumference of the ring. Big R d theta is the thickness of that ring because of arc length. Okay. Let me look at the thing that Hardlocked put in chat. Or in the Discord. Oh no? Should I look at it later? You can? Okay. Are you saying, oh no in general? To show that 2 plus 2 equals 5? Okay. Oh, it's gonna be one of these. Okay. I don't see the logical error yet. There's no equal signs. I mean, that's an error, but... Oh, you can't divide by 0. 2 minus 2 is 0. You can't do that second to last step. Or like that last thing there. Yeah. It's that divided by 2 minus 2 on each side. That's the error. Nice. Okay. So Fenvox is right. That should be RD theta. We still need to get rid of that R, though. And for I'm trying to prove the derivative of arc sine with implicit differentiation, I guess. D theta dr. Oh, what is that? I'm going to call that script R, even though script R looks completely different. 1 over r cosine theta. Is this when we say we know that theta is equal to arc sine r over r, and we plug that in down here? Yeah. And then I feel like this is pointless what I'm doing, or like I feel like I already drew that triangle up there, but cosine of this thing is adjacent over hypotenuse, so it's 1 over r times adjacent over hypotenuse. Root r squared minus r squared over r. Really? 1 over root r squared minus r squared? Feels weird that the big R's cancel, but the math does indeed not check out. Yeah, hard-locked. You're not allowed to divide it by 2 minus 2. It's just fancy. Like, you may as well just divide each side by 0. Up until that point, though, you know, he was doing some fancy stuff. So what did I just find out? D theta by dr is this thing. So d theta is this thing times dr. 2 pi r, wait, no, I'm doing the wrong thing again. Why did I do all this? I'm trying to get rid of r. I don't care about dr or d theta. Why'd I take the derivative? Just little r is equal to big R sine. Oh my god, I'm doing things. I'm just doing unnecessary math for fun right now. Little r is big R sine theta. That's literally all I needed. 2 pi big R squared sine theta d theta. Okay. I don't know what the hell I was doing before. Integration by parts. Welcome in. Just failing at some physics right now. How's it going for you? All right, so that's dA that we got. That means dq is sigma dA, which is sigma 2 pi sigma r squared sine theta d theta. Okay. So our field at the center is going to be dq over 4 pi epsilon naught the distance, I guess, is it's always big R squared? That feels wrong, but I think it's right. And because we only care about the component pointing up, we're going to take a cosine theta. All right, so now we plug in for dq. R squared sine theta, d theta, cosine theta, 4 pi epsilon naught r squared. So the r squared are going to cancel. Good, you have a stats and mechanics paper, then you're done with your A levels next Thursday. Nice. Yeah, FemVox. I'm wondering what it was now too. I just really felt like proving what the derivative of arcsine is. Apparently. Sorry, that's DE. Like that. So E is equal to integral DE, which is equal to integral two epsilon naught integral 0 to pi over 2 is what theta should range from. Sine theta, cosine theta, d theta. I'm going to take u equals sine theta. du is cosine theta d theta. So we get sigma over 2 epsilon naught. One half sine squared theta from 0 to pi over 2. Sine of pi over 2 is 1. Sine of 0 is 0. Sigma over 4 epsilon naught. That should, okay, good. That's right because of what part B is saying the answer is. Because for part B, To get it for a solid hemisphere, you think about it in terms of hemispherical shells, and your big R is now what's changing. So we integrate the thing we just got, sigma for epsilon naught. We're going to integrate it from 0 to R in terms of big R. This is going to be sigma R over 4 epsilon naught. Oh, it's still lagging for you, Fenbox? It's annoying. I'm sorry that's happening. Have I given you my sequence challenge problem? I don't think you have. I don't have confidence that I can do it. What did I just do? Oh, no, I'm fine, I'm fine. Man, I'm not I think it's just the Twitch servers being dumb. So I'm not dropping frames. Dude, my nose is so itchy. One second. Oh my god, one second. I'm just gonna go blow my nose, dude. This physics will keep you entertained. Okay. Uh, this reminds me of a sequence. I don't think it's the same one, but it's related to Fibonacci numbers. It's called the Zeckendorf sequence. This is basically a Project Euler problem, I think. Uh, it looks like prime numbers are getting mapped to themselves. Four seems like an odd number out. It's the only even number besides two. Or, you know, it's only getting mapped to an even number. Or hell, it's the only thing getting mapped to a non-prime. I don't. It was like a whole bunch of fives. I don't really see what's up with it though. I don't know why some of these. Oops. Yeah, I don't really know corrupt. I really don't see the pattern in this. If I'm gonna do a challenge problem, I'm gonna do the physics challenge problems that I'm more interested in, I think. So I don't really have much to say about this. Like I am just kind of stuck. Um, there's probably some kind of interesting sequence in here, but I don't know. Yeah, it's just a challenge problem. I'm gonna go back to doing the physics stuff because I don't know, I think these are fun. Something pretty simple. I mean, if you're willing to spoil it, feel free to say it, but if you don't want to spoil it, then I understand. Um, it's our Oh, okay. Yeah, that's fair. Okay, so for this frickin' hemispherical shell. Hey, Gold. Oh, wait, okay. Spherical shell would be nice. It's called a point charge. Oh, yeah. So this is one, I think I tried it last week or something. And I was just getting nowhere fast. I want to try it again. I forget what I was working on first. I think I was working on, we had to use, we have to use law of cosines. I think I was working on maybe inside the hemisphere first. So maybe let's do we just find the potential and compute the gradient? Oh, I mean, we haven't done anything like that in the book. I think they want you to do some ridiculous integral with Coulomb's law is the intent. The potential. I know there was a different question where they had you figure out the potential and take the derivative. Is it possible to do it that way too? Yeah, so like, I don't know how the integral is going to get set up, but it's going to be like some kind of ridiculous, like, I shouldn't do it like this because I don't know if it's going to be the same for like inside the hemisphere versus outside. So I was thinking like do them separate. That's a weird Z, dude. What the hell is wrong with that Z? But yeah, like we could definitely do some law of cosine stuff with this. Bunch of rings, yeah. So yeah, that would be a ring like right there. And that ring would have radius small r, which I think we can work out. We have right triangles, like this big r radius forms a right triangle with this small r. So dA is 2 pi small r. Oh, what are we going to call theta? Theta, I guess, is the angle in there. Oh, geez, it's a tiny theta. 2 pi r big R d theta. Just do it for the field at the origin first and then extrapolate. Oh, you know what? So I actually, I actually just erased that. I haven't seen problem 50 that was similar and it was asking that same question. I should have, oh God, what was the answer? Because that one, it was just like, okay, yeah. So, this is the field at the origin for a solid hemisphere, but you take out the big R, and that's what you get for a shell. So, I guess it'd be sigma over 4 epsilon naught. I don't know how you would extrapolate that. Like, we just scale that with something with z? So, like, I could imagine it to be like root r squared minus z squared or something like that, but it feels kind of like I don't have an explanation for like why. I'm just kind of like arbitrarily saying that, I guess. Hmm. And regardless, I want to go through like the pain of doing that crazy integral because I feel like it's gonna build character, I guess. But if there is like a shortcut way, that's good to hear about too, I guess. Um, well, I should be careful with my R's here. No, well, no, that's actually the right R. I assume I get everything in terms of theta, if we can help it. So this little r is big R sine theta. So get big R squared sine theta d. This black marker is dying. dq, we just slap a sigma on this thing. R squared sine theta d theta. And then the field. For now, I'm just gonna say 0 is less than z is less than r. This might be valid in more places. I don't really know how this is gonna work yet, though. It's equal to dq over 4 pi epsilon naught. Now, I need that third side of the triangle squared. So if we love cosines that thing, it's going to be z squared plus r squared minus 2zr cosine theta. And we plug in our dq, our Dairy Queen, 2 pi sigma r squared sine theta d theta over 4 pi epsilon naught z squared plus r squared minus 2zr cosine theta. And that's going to integrate from 0 to r? Or no, not from 0 to pi over 2. Even for the sequence, all the information is held within the values serving as input. Oh, really? It has a closed form, I guess? I mean, the Fibonacci sequence has like a closed form too, but we don't usually like show it. All right, I guess let's try integrating this thing from 0 to r. Pi cancels, the 2 kind of cancels. We have a sigma big R squared, 2 epsilon naught, 0 to, oh wait, no. I keep on doing that same mistake. Oh wait, z, we're taking z as a constant. So, okay, yeah, that's fine. So sigma's going, or theta's going from 0 to pi over 2. No, from pi over 2 to, well, it doesn't matter, I guess. Okay, I don't know. Sine theta d theta over z squared plus r squared minus 2zr. I feel like this is a little cooked, but sounds good. Corrupt. It looks like a mess, but the U-sub would clean this thing right up. One over 2 c r u du. These are all constants that can go up front. ln 2zr cosine theta from 0 to pi over 2. You have no clue about this, dude. 4z epsilon naught. Okay, pi over 2, we get 0 there for cosine. So we still have ln z squared plus r squared minus ln cosine of 0 is 1. Is there a way to clean this up? That looks stupid, right? I don't... Does that factor? Oh, I guess it would factor, but it's not going to cancel the top. Oh well. I have no clue this is right. I can pretend it's right and try and calculate. I guess maybe we can do below the shell now. What is that line? Just spaced out there. Okay. Now the theta here would be kind of tricky. What angle do we want to track? Because, like, that angle down there seems natural, but, like, I have no idea what theta would range from there. Well, from 0 to something, but what would the upper bound be? It would depend on z, I guess. Did I already make a mistake? Is z dependent? Or, like, theta and z are related. Was it okay to just have taken z as a constant like I did? Man. I'm gonna cheat and look a little bit more of the answer. I'm not gonna scroll all the way down to the answer, but I'm gonna look a little bit more of the answer than I did the last time I tried this problem. Let's guess 650. Oh, it's not too far off. Try 620. Isn't it? I could have sworn I should have looked at what problem number it was. Oh, this is chapter 2. That's why it looks so different. That's not my problem. 12. Okay, here. I forgot a piece. Why are they doing sine? Oh, wait, what the hell? I forgot about this piece. Right here. Hey, Scorpio. She, indeed. Yeah, I feel like I did the exact integral I have on the board before and I got the same answer. How's it going, Scorp? Pretty good. That's good to hear. So they define phi to be that angle there. Oh, I see. God, that's such a weird thing to have to derive. Okay. We can do it, though. If I need to go back to this page 594, I guarantee I'm going to forget that. Okay, and once I do that, we should have the right integral set up. Hopefully. If we cross our fingers hard enough. Get rid of that. Get rid of most of that. All right, I need to put a factor on this thing to account for the direction of the field, or like just the one component of the field. So it won't be easy. So I like the right triangle that they drew. I guess this situation right here. That's little r. That is z. That is theta. Oops. Why can't we just put a cosine theta? That seems weird. Why do I have to do all this work with the angle phi when we already have this theta? Why can't we just put a cosine theta right there? Like, it's not going to give us the right constants, I guess, but... Sine of phi is opposite. Which is z plus r cosine theta over hypotenuse, which is r. No. I'm using slightly different variables in the book. Because phi goes with that hypotenuse and that opposite. R cosine theta minus z over root z squared plus r squared minus 2zr cosine theta. Disgusting. Disgusting. I mean, it's the same thing the book should have, though. They just wrote a little bit cleaner because, They call like that when they're small r, I think, and I chose a different small r. But you should still get that stupid looking thing, I guess. Plug in the DQ again. R squared sine theta d theta. R cosine theta minus z d theta over 4 pi epsilon naught z squared plus r squared minus 2z. Can't write, dude. To the 3/2. What a stupid integral, dude. This is gonna suck. They probably phoned this integral in. I guarantee you. You integrate that thing from 0 to pi/2, I guess. I'm looking back at the answer key though. Okay, so I've now gotten to the same thing the book has. Okay, yeah, how the hell do you do this integral here? That's what I was seeing. Where does that minus sign come from, by the way? Of minus sine theta? Why is it minus sine theta? Because it's in the negative z direction? Interesting. That solves the riddle of 0 to pi/2 or pi/2 to 0. It happens to be doable in closed form? Okay, but they do just say use an integral table or Mathematica. How? I'm curious how you do such an integral. Sine theta, cosine theta. Oh, I use Wolfram all the time. It's my specialty. Oh. I mean, not using Wolfram Alpha is just a waste of time for certain integrals like this one. Huh. Why wouldn't Wolfram Alpha use u equals 1 minus cosine theta? I feel like that'd make the resulting integral a little bit simpler. What does Appendix K tell us? Oh my god, look at these complicated integrals they have worked out for you. Look at that. That situation comes up often enough, it makes it into an integral table, dude. Okay, no, I mean, I know I have the integrals set up right, so let's do it the way the book intends. I just want to feel confident that I don't have to actually integrate this thing by hand. Because that's terrible. Minus, minus, minus. Two ZR cosine theta. Okay, so when we go to integrate this, we have constants minus sigma r squared over 2 epsilon naught integral from 0 to pi over 2 sine theta r cosine theta minus z over z squared plus r squared minus 2z r cosine theta d theta. And now from the table, a cosine x minus b. Okay, so a is big R. So minus R plus z cosine theta over z squared root r squared plus z squared minus 2rz cosine theta. Interesting, let me get that. 0 to pi over 2. Huh. Okay. I guess I see where that comes from. Yeah. All right, so theta equals pi over 2. Cosine of pi over 2 is 0. So we get a minus r on top, a z squared root r squared plus z squared there. Now when theta equals 0, cosine of theta is 1. R squared plus z squared minus 2rz. And that's it. I think this will simplify because that thing is z minus r squared. C squared times Z minus R. Ooh, those things cancel to -1. Okay, we get a common denominator for this thing and really make it look nice. You can bring the negative sign inside here. Top of it just R minus R squared plus C squared over C squared root R squared plus C squared. And so if Z equals 0, we get R minus, oh, we divide by, okay, this thing is invalid for Z equals 0, actually. I don't know what to make of this other than it exists. Let's check that result, I guess. Okay, yeah, Jed, some other people mentioned it, although I don't think if they did check out the streams, they didn't mention it. I'm glad it's not just me then. Unfortunately, there's not much that I can do, it sounds like. And the sign of R minus Z. Oh, so this is valid for not just inside the hemisphere. If R minus Z oh. Oh god. Oh, that did not wake me up, evidently. Dude, I like my jaw is like cramped from that yawn. That's how big it was. God, that lag is brutal. I'm probably gonna stream for that much longer anyway. Like once I get through this problem, maybe. That, yeah, I mean, this is a long problem. It's a 3-star problem. I think I'm a 5-star streamer. I appreciate you, Jed. Wow, this turns out to be valid for every Z. You just have to flip a sign depending on whether Z is less than R. So about a pentagram in a basement, so me from the pits of hell. I'll take it. No! No! Oh, I see. They factored the R squared from the denominator here and canceled the R there. Okay. Huh. Is that just the end of the solution right there? Okay. Yeah, Jed. I turned them off for YouTube because I'm worried about copyright stuff on YouTube. It does kind of suck that, like, you know, most of my alerts are either audio only like that one, or like if someone follows, it plays like, you know, a clip from a TV show or movie and they just see the visual of it and don't actually hear it. I just don't have a good solution to that problem, to be honest. So I just let it be a stupid solution, I guess. Like, I see, like, I mean, I don't imagine I'll have this problem for a very long time, if, and probably never, but I've seen, like, a big YouTubers talk about how they just arbitrarily get copyright claimed all the time, even if there's no music in their video, and YouTube believes the claimer, so they demonetize the video until it can get appealed. But like during the time that's appealed, they're not. It's like the most important time for the video, and like where they make the most money. So background sound effects may just Phasma or played up, or code names. Code names is too hard to organize. But yeah, I mean, I guess my own sound effects are the easy solution. That takes work though. The thing that I don't like, I love playing code names. The thing I hate about organizing code names is that it's risky, because if there's less than 6 people, I just feel like the game doesn't really work that well. And getting 6 people to commit to the same time in the same day is difficult. Do me to, I mean, I think that's 3, but um, oh yeah, true. Evil Talos. Dan was talking about trying to get some tabletop simulator going. There's one game that he mentioned, potentially being a good game. I forget what it's called. Something about a haunted house or haunted something or other. If C is less than R, the field points downward. I guess it makes sense. Epic spell. That was the one that Dan said. Is that one that you're suggesting to play? A pillbox spanning the surface? What? A pillbox? What shape is a pillbox? How does this integral apply to every possible z? It really seems like it shouldn't. Like, theta is going from 0 to pi over 2. It makes perfect sense if z is inside the hemisphere. This definition of theta makes no sense to me for when z is not inside the hemisphere, though, is what I'm trying to figure out. Like, why would it still go from 0 to pi over 2 if z is below the hemisphere or above it? Hmm. Angle theta down from the top of the hemisphere. Why is the top of the hemisphere on the bottom? What? Oh my god. Top of the hemisphere, and their figure has theta on the bottom. The top half of the hemisphere? It's like, as in like a quarter of a sphere? Or do you mean like the hemisphere as half of a sphere? Hey, Anders. How's it going? Okay. I mean, maybe they do. Well, they say the angle theta down from the top. They're no, I don't think they even mean that, Jed. Like angle theta down from the top of the. I think they just flipped it in the figure. It is a precise language. I'm doing good. This is from the Electricity Madison book I've been doing the reading group for. Just been working on this problem in the downtime since there aren't questions from chat. And I'm working through the book solution because I just could not quite get it for myself. I needed quite a few hints. And I'm trying to figure out why the solution the book gets is valid everywhere. Because they construct it with the point Z inside of this hemisphere. But it apparently works for a point outside the hemisphere, above or below it. And that's crazy to me. Does the law of cosines take care of it for us for any invalid thetas? I don't know how that command works. I would need to look back at what Enigma wrote. Yeah, okay, I can't explain how the book's setup is valid. I'm just gonna keep reading. I don't understand this Gauss's law application either. No, this isn't like the official like reading group. That's been happening on Saturdays. I've still been trying some of the problems during the downtime because there's like 80 something problems in chapter 1, so it's not like we're gonna run out of anytime soon. But yeah, I mean, of course, if anyone from the reading group wants to like talk about it and they haven't to catch me, then I'm happy to like talk about it too. Hey, Critical. Hey, Dr. L. So what's all this other stuff now? Oh yeah, sure, Anders. Atmosphere looks like a point charge from far away. Ooh, okay. For z approaching 0, you can use 1 over... Oh... That's how you get the normal... Okay. Yeah, I'd be happy to take a look. Let me know when you post it, or if you just type it on chat, I'll see it. X ln the sine of x. Is x approaches 0 from the right? What? Okay, so if we try to just plug in 0, we get 0 times ln of 0, which is negative infinity. So that's indeterminate, and we could L'Hopital's, is my first instinct. Let's try it. Oh. Okay. When is x approaches 0 from the rate of x ln sine of x? Good riddance, problem 12. I mean, I'm still not done reading the answer for problem 12, Fembox, but I need to think about it more. Oh god, Dr. L. I'll look at that in a second, but I'm guessing the answer is 69. No worries, Anders. I can type back to you in Discord or something too if you completely miss it. A lot of people have been complaining about lag on Twitch today, so I don't think it's just you. I think Twitch is just having troubles. All right, so I'm going to rewrite this as ln sine of x over 1 over x to allow me to use L'Hopital's here. Because I want to get rid of that ln, ideally. 1 over sine x times cosine x over minus 1 over x squared. Let's simplify this thing. 0 from the right. Cotangent minus x squared cotangent x. Is that anything simpler to evaluate? No? Can't be that predictable every time. You have a reputation now, Dr. L. Did I make a mistake already? This is still going to be, check the derivative of the numerator. Yeah, Dr. L, Twitch is being laggy, unfortunately. Derivative of the numerator. Yeah, I don't see what's wrong with it. Yeah, isn't that just what ln of sine of x derives to? Oh, it's a typo? Okay, no worries. The issue is this isn't really any easier to evaluate, is it? Because cotangent, I'm pretty sure it looks like that. And when it approaches 0 from the right, that's still negative infinity. Cotangent is going to derive to like cosecant squared or something weird. Yeah, I think it's like minus cosecant squared. Does that help us? I don't think it's going to help us. I don't think L'Hopital is going to help here. We're always getting an indeterminate form no matter what I can think. Which makes me think you gotta do a Taylor series. I don't know how else you'd possibly evaluate this, unless there's some clever squeeze theorem thing. Well, could you make the claim can you make this claim? Actually, probably not. X isn't greater than sine of x, necessarily. It's about the same as sine of x for small angles. Yeah. What would the Taylor series of, I guess, that bit look like? Centered at 0, I guess. So the first term of the Taylor series is this thing plugged in for 0. Sine of 0 is 0. Oh, well, that's not good, is it? You can't center a Taylor series at 0. It's not defined at 0. Where would you center it? Can you do like pi over 2 to give you clean numbers? Shouldn't matter where you center it, I guess. You should end up with the same answer. We expand ln of x and multiply the expansion by x. Oh, we should try exponentiation, Fenbox, you're right. Yeah, Dr. I think I was going in your direction with trying to get a Taylor series for this thing and multiplying the x in. But Fenbox raises a good point of we should probably try exponentiating this. How does exponentiation work? Are we doing the sneaky trick of assuming it converges? And then we do e to the power of each side? Zero to the right. Sine of x to the power of x? Do you have to exponentiate again? I mean, you could do a small angle approximation, I bet, but sine of x is about x. I worry, or no, sorry, you wouldn't, I guess, would you do the ln? No, that's just gonna undo what we just did, though. What the hell? Wait, okay, so how do you do... Let's go 0 of x to the x. Like, you do the same thing. I said do. Or no, you would... Here you would take the ln of each side, would you not? No, because then you get ln of 0. Why do I forget the trick? Is it e to the x? Oh, wait, that's what you do. Okay. I think I just did this wrong. Well... No, wait. No, never mind. This is such a weird limit, dude. This is why you love physics. Okay, I don't know if exponentiation is helping us either. I'm getting really weirded out by everything that's happening here. See, I would say it's probably a Taylor series then. And the first term is this of a. Sine of pi over 2 is 1. Ln of 1 is 0. The second term is f prime of a. F prime x equals... So does cotangent x? Cotangent of pi over 2, 0. Oh. Is this, what do we get now? I think that's minus cosecant squared. D by... Oh no, I can't do that. I didn't know if that was true, Jed. I know that sine of x is about x. This is right. I don't know if it's less than x. This is such a pain to get these terms. But, so cosecant is 1 over sine. So -1, we finally get a non-zero term, I guess. This is just gonna... This isn't working out how I hoped it would. Oh, a Taylor series. They haven't learned that yet. Okay. Feel like a noob every day? I sure do. Is that allowed, Dr. L? I don't know. I feel like it wouldn't be. I don't actually know that though. It's gotta be. And for a second, I was wondering if it's like complex variables, but I doubt that. Or maybe there's a complex variables way, but we should hope we shouldn't have to use it. It's gotta be some like clever squeeze or something. Yeah, sure, Jed. Because we get the bounds. When you do sin x over x, you can like bound. We could bound that sign and try to work from there. So let's look at. Oh, it does look like, at least visually, it seems like x is greater than sine of x. I don't know how you really prove that. But it seems like XL and X would be a valid comparison. Thing is, we need something on the bottom. Like, we need like a lower bound as well. That's what I mean with like, we need a bottom. And it's not so clear to me how you do that. I know, Anders, I'm so tempted to just plot it. Let's limit, okay, I just want to remember. These are not the bounds that I remember. These are not the bounds that I remember. No. I doing an epsilon delta for this, I don't know what the hell that would be. This feels so much like we're going to get sine x over x. It's almost like, oh my god, I so want to make it like sine x over x. I just can't figure out like how you would do that. But I think about these functions intuitively. So x is just becoming 0. ln of sine of x is becoming ln of 0. And ln of 0 shoots out to negative infinity. And I have a feeling it would do that a lot faster than x approaches 0. So maybe if I were betting intuitively, this thing is going to diverge to negative infinity. But that's not a proof, and I don't know that. I'm not sure. It matters how you get there. It matters like at what rate you approach 0 and infinity from, I think. So I don't know if it's actually going to be negative infinity, but I'm thinking that, like, you know, the end of the logarithmic function that's approaching 0 from the right is like exponential growth, but towards infinity, or negative infinity, versus linear growth or decay towards 0. Partial fractions. Partial fractions. I don't know what we're doing partial fractions with here. I mean, you can integrate partial fractions. I don't think it's going to help us with the limit, though. I'm curious if there's some kind of limit trick that I'm forgetting about. Oh, okay. Are there any log identities that might be helpful? This might be really stupid. I want to see how something is going to turn out, though. X is approaching 0, but it's not going to be exactly 0. So what if we multiplied by x times 1 over x sine x? And then we use a log identity, because the log of a product is the sum of 2 logs. Is that helpful? A backwards Lopple? Oh yeah. Even Wolfram's just doing... Yeah, so the... I didn't know where that leads though, Jed. Unfortunately, Wolfram probably won't tell you where it leads. Wait. Sin of x over x approaches 1? ln of 1 is 0. That's just 0 times 0. Can we make the claim this thing is 0? It's not indeterminate, so I can't really L'Hopital's it. Thanks for the 4 months, Anders. Appreciate you. Can I just say that... I think I could just say that that's 0 because it's the product of two convergent limits that are both 0. And this we could L'Hopital's. This is 0 from the right. Of minus x? Is it 0? Did I... Am I a genius or am I stupid? Or both? Tartar, can you do 0 is the right answer? Okay, so I got 2 of the right answer. I couldn't tell if my steps are that valid. That's an interesting idea, Tartar. Does x to the x approach e? I forget. I feel like it approaches E. No, it approaches 1. That would give you ln of 1, which would go to negative infinity. It doesn't get the right... Apparently the right answer is 0, Teratar. I don't see what would be wrong with that approach, though. Oh, I do already have it open. ln of 1 is 0. Oh, you're right. I was doing ln as x approaches 0, but it's ln of 1. Yeah, Territar, I think that would be valid too. Okay. So let me write up on the board what Territar is saying so Twitch can see it too. How do you justify the limit of ln with sin x over x? So Actually, let me quickly say what Tortilla over on YouTube is saying. You could rewrite this as ln, oops, of sine of x to the x, and then use a small angle approximation. To say x to the x, which would be ln of 1. Oops, not about anymore. Because x to the x approaches 1, and so ln of 1 is 0. But if I were to justify it this way more, to do the limit of this bit on the right here, I was thinking this is the product of two convergent limits, so we could write it as x times limit as x approaches 0, ln sine x over x, and sine of x over x just approaches 1. And this x is just 0. So that's how I was just finding like that part there. Just sine x over x approaches 1 and ln of 1 is 0. It's kind of like I'm really bad at the limit properties, so I feel like I might have like misstated something, but that's how I was rationalizing it. Now, what does this function look like? I need to know. Whoa. What? What is this? I guess that makes sense because of the sign. I forgot the sign was in there. What a crazy function. So, my way of doing it is kind of crazy. I much prefer what Teratar said with using the small angle approximation, but I don't know if every student is taught that. I kind of like my way just because of how crazy it is, but it feels like such a bad way to do it. I feel like there should be a better way. Or like, what way did you come up with, Anders? Like, I'm curious. How does Wolfram say to do it? Multiply and divide by sine. Oh, really? Like on the outside? Oh, that's a good question, Dr. L. Is it? Do we get discontinuities in this? Like, it should be discontinuous at x equals pi. It seems... Oh, it's hard to tell with all the... It seems like it might be discontinuous at multiples of pi. I can't really tell, though. Yeah, okay, the discontinuities get lower and lower each time, it seems, but... I think it does have breaks, like, all the way down there. At y equals negative infinity? I gotta know, Jed. Um, I'll hit negative infinity eventually. I just need infinite time is all. Dang, yeah. So limit property. Oh, okay. Yeah, x over sine x should still be 1. And sine of x will be 0, and ln of sine of x. ln of sine of x. Oh. Okay. See, the ln of sine of x is still an issue. You gotta do some work to deal with that. An interesting limit, though. Kind of funny that we had a similar idea of multiplying by something over that thing. Are there any questions that I'm missing? Or like, is there anything else in that question? I might wrap things up since Twitch is being kind of glitchy today anyway. But I don't want to cut things off if someone still has something to say about that problem or if they have a new problem to bring up. For another like 30 seconds, and I'm gonna call things. Oh yeah, Dr. L, you're right. How could I forget about your torts? Let me bring up that problem again. My torts. Forgot about that. Okay, so that's the problem that Dr. L posted. I'll put it in the YouTube chat too. Oh wait, it's too long for the YouTube chat. What about this? Let's even put it up on the big screen. This problem that I bet will be 69. I can make 12 of the best tortillas out of 3 cups of flour and a third a cup of olive oil. Ah. Okay, cool. 12 of the best tortillas out of 3 cups of flour and a third a cup of olive oil. That's... I feel like those things are... You're basically have a bowl of flour with that ratio, but okay. I think you need some more liquid. I haven't tried with olive oil, though. $5.50 for 5 pounds of all-purpose flour and $20 for 50 fluid ounces of olive oil to make one of the best flour torts you'll ever taste. Salt, water. Oh, okay. Well, I guess we gotta figure out how much flour we're using per tortilla. Oh yeah, we do need to figure out the density of flour. I'm gonna... I've actually Googled this exact thing before. How many cups of flour? Or no, wait, yeah, in a 5-pound bag, I guess. And not the exact thing, but basically the same thing. 18 cups. That's one of the first thing I see. Oh, this one says 20. Walmart lies. I mean, no. This one says 18 to 20. 19.9? Thanks for the exact answer, Cora. I'm just going with 18 because it's the first thing I saw. No, I believe that Walmart says 19. I was going to say, I mean, I'm a little bit worried that if I'm supposed to get a meme answer, I might not get it, but we'll just roll with 18. So there's 18 cups of flour in a 5-pound bag of flour, or yeah, we're going to say. And you need 3 cups of flour. $76.25 cup servings? You made a cup, you got 4.9 ounces? Oh god. Alright, you know, we're gonna go the extra mile and do that conversion then. If 1 cup is 4.9 ounces... Dude, what the hell? 16 ounces in a pound? That's so stupid. Why do our units work like that? It's 4.9 over 16 of 76 servings of a quarter. Oh. I misread. Dude, yeah, that's one of the ways that they can mess with the nutrition labels. They just mess with the serving size, and it looks like it doesn't have that much sugar in it or something like that. I don't know why they would do that for flour, but... Mangoes, thanks for the work. So what is this? That means we have 0.3 pounds of flour in a cup. Yeah, you're right, Chet. So 0.3 pounds of flour is in a cup. And we have 3 cups of flour. So we multiply it by 3 to get 0.91. Context gets some? Oh, I don't know what I said. You know, whatever I said, just interpret it in the worst way possible. 3 cups to make 12 tortillas. Do we just divide by 12? Wait, I already lost track of what I'm doing. I need to write this on the board. Ugh, okay. Okay, so we got there is 1 cup and 4.9 ounces. And we want... I was converting that to pounds for some reason. Which we can do. Yeah, because we know the cost per pound. So I'm going to say 4.9 ounces per cup times 1 pound per 16 ounces. That was the 0.3 number. Start with... Oh, yeah. You're right. I probably should just end with the dollar as the numerator, but I don't know where I'm going with this yet, I guess. 3 pound or 0.3 pounds per cup. 0.31, if I'm rounding right. And so now we want to do cost per cup. LB per cup times, wait, yeah, a bag of flour is $5.50 for 5 pounds. Okay, I'm keeping everything exact in Wolfram, Jed, just to make you happy. Like, I'm not going to delete any of my previous work. I'm just going to keep adding on multiplications to it. 0.34. $0.34 per cup of flour. That's what we're saying. Keep him honesty. Yes, Jed. I'm tracking it all. What's next? So we're asking for just one. Is tax included? Oh no. Gonna get into municipal taxes? So 3 cups of flour makes 12 tortillas. Equals a fourth of a cup per tortilla. So we're gonna do 34 cents per cup of flour times a quarter of a cup per tortilla. Yeah, there's one for Evo. Can you use it? Okay, 08. 8 cents per tortilla in flour. Hey, Brave Teddy. How's it going? Welcome in. Okay, so that's the calculation for flour. We're working on this. I assume the problem's gonna have a meme answer, but I'm just taking the bait anyway. Can we use an abelian group here somehow? I mean, this multiplication is commutative. It's good to hear, Teddy. So a third of a cup of olive oil. Oh, we gotta convert the fluid ounces of olive oil to a cup. That's at least cleaner because it's a liquid, right? Oh god, I just hit something and I don't know what that thing was. Sugar. Nothing about sugar, just sugar. Sorry. I know it's so funny to me. Just people Googling sugar a bunch, I guess. Yeah, PJ Salt. I then like density of olive oil in, what would it be? Fluid ounces per cup? That Google isn't gonna do the work for me. Oh, do they have the same chart here? Okay, yeah. A third a cup of olive oil is 1.53 ounces. So we need to convert the fluid ounces, or we can convert the cups to fluid ounces, or wait, which direction? Dude, I'm losing track of what I did. Even the ads are pausing? Oh no. Dude, unit conversion is the worst. $20 for 50 fluid ounces of olive oil. Fine, Doc, sold to you. Dr. L, thanks so much for the prime. Holy crap, I appreciate you. You know, it is easy to like set this up, or like, you know, it's easy to like set up the cancellations, but like when it gets like this, it's like a lot of work. Enigmabot thinks that's a command. Dollars per ounce times the ounce per cup. Okay, Jed. I guess we have $20 per 50 ounce. Times 1.53 ounce per third of a cup. And then times a third of a cup for 12 tortillas. Okay, that makes sense. Well, something. Eight ounces per cup? Oh, do you just measure that, Dr. L? We can use that instead. Yeah, let's use that. That's kind of a very like different density. I wonder if it depends on like the quality of the oil, or like different types of oil have different densities. 8 ounces per cup. Now they don't cancel Jed, so the joke's on you. Fluid ounce is volume? To be honest, I don't know what a fluid ounce is. I know it's a volume now, I guess. 8 ounces. Okay, I guess those are fluid ounces. I wrote just ounces. Why do something called an ounce? It's not weight. Either way, the number should be right if I'm calling the units slightly wrong. Times 8 times a third times a 12. Basically 9 cents. We can take this, add it to the calculation for flour. It's not 69? Okay, I guess it's 17 cents per tort. Sorry, you know, not tortilla, but tort. Unless I did something wrong. Dude, that's quite the rational number right there. Yeah, I mean, for a tortilla, 17 cents per tortilla. That doesn't seem such an amazing tort. 60 cents? Oh, nice. Dude, carnitas sounds so good. Um, you know, I was at least hoping for like 420 or something, you know, but oh well. Tacos for dinner tonight? Oh my god, you guys are making me want tacos. Weren't the best torts? Were they store-bought? Yeah, sure, Dr. L. Zero net carbs. Oh, that'll do it. I love carbs personally. Oh yeah, Amorphous. We were doing that one right before. It is possible. It's a really tricky one. What Tara said is probably the simplest way to do it. And it's X approaches zero from the right. I found a crazy way that you can do it too, but low carbs too, your body. Yeah, that's fair, Jed. Direct sub? I don't know a direct sub that would help there. Dude, like whenever I make recipes, they never come out as photogenic as like these recipe websites have pictures for. I don't think I've ever made flour tortillas. I make corn tortillas pretty frequently. Don't use a mixer. Yeah, I do. So an X value a little greater than zero? Oh, yeah, amorphous. That's like called, that'd be like a numerical method, which is not considered a proof. You can use that to figure out what the limit should be and then try to prove that, but that's not really a way that you would do it on like it on a test in like a calculus class. They normally want you to do some kind of math, or like they don't want you to just plug things in. They want you to use like limit identities and things like that. Yeah, like tortillas fresh are really nice. This recipe doesn't seem too bad though either. No worries, Dr. L. I probably am gonna wrap the stream up then. So Amor, if there any last words from you, I'm gonna probably wrap the stream up, or I'm gonna like cut the YouTube stream up in a minute here or so. Someone has to talk with the brain. I really do. You can be 420. Thank you, Dr. L. You know, I really need my meme problems. Okay. So yeah, I'm cutting the YouTube stream off here. So Amorphous and Animals who's here on YouTube. I appreciate you. And I'll be back on YouTube. You kind of should. If you just go back in the VOD, I solved it on the whiteboard. It was the problem I did like right before this tortilla one. But yeah, I'm gonna cut the YouTube stream off here. So sorry about that, Amorphous, but I hope you have a good day, night, evening, or whatever, and I'll see you around. Over on Twitch, we're gonna go raid out to someone here. Yeah, you too.